Hello everyone, welcome back to the course Information Theory and Coding. In the last class, we started with solving a problem which is related to Shannon's Fano encoding algorithm. Today we are going to continue with a few more examples. Okay, so let us try to solve this example. So what they are given you, a source produces two symbols A and B with the probabilities values 0.05 and 0.95 respectively. Construct a suitable binary code such that the efficiency of the code is at least 48%. They have asked you. Means what? You need to create a source vector, that is a code vector, which is having a efficiency at least 48%. We need to find it out. Okay, so let us try to solve this by using a Shannon-Fanon encoding algorithm. So in order to do that, so what are the first two symbols we have is, so the first symbols we have, that is, let us call this is a symbol which is emitting with a probability 0.95, and this is the B symbol which is emitting with a probability 0.05. Okay, so now what is the first thing is, you need to arrange the symbols in a decreasing order of their probabilities. So if I write is, the first one will be 0.95 and the second one you will be getting 0.05. Since you have only two symbols, so therefore I will group this as a first group and this I will group as a second group. So if I group that, so what I will be doing is, I will be assigning a code vector is equal to 0, and for the second group I will be assigning the value is equal to 0. So therefore the code words for the A, so now if I write the code words for the A, so if I write the code words is, so this is 1 and this is 0. Similarly, if I want to find out the average code length for this is, so this will be 1 and this is will be 1. Now what I am supposed to do is, I need to find out the average code length, that is capital L. So how we are going to find out the average code length capital L is nothing but summation I is equal to 1 to q pi into li. You are going to do it. Since there are only two symbols are there, so therefore summation I is equal to 1 to 2 pi into li you will be getting. So if you do that, so what is this pi? That is nothing but 0.95 into 1 plus 0.05 into 1. So if you do that, you'll be getting 1 bits per symbols, you'll be getting 1 bits per symbol you'll be getting. Okay, so this is what the average code length we are going to calculate. Now what is the next thing is, you need to calculate the entropy of the source. So what is the expression for entropy of the source? That is nothing but h of s is nothing but summation I is equal to 1 to q pi into log 1 by pi 1 by log by pi. So what is this? So there are two probabilities are there, that is nothing but two symbols are there. So p1 log 1 divided by p1 plus p2 log 1 divided by p2, and by default we are taking the base always it as a 2. So if you substitute these two values, that is nothing but 0.95 log 1 divided by 0.95 plus 0.05 log 1 divided by 0.05. If I substitute that, so you'll be getting, what is the value you'll be getting is 0.2864 bits per symbol you will be getting. 0.28 bits per symbols you'll be getting. Okay, so if I substitute that, so you'll be getting what is h of s is equal to 0.284 bits per symbols you'll be getting. Now what my job is? My job is to find out the efficiency. My job is to find out the efficiency. What is this efficiency? It is nothing but h of s divided by the average length. What? So if I substitute this 0.2864 divided by the average length, what is that? So if I substitute is equal to 1, so you'll be getting 28.64% you'll be getting. 28.64% you'll be getting. But what they ask, you need to construct a code words in such a way that the efficiency, it has to be 48%. You need to get it out. So now what is the next thing you are supposed to do is, so but in the problem whatever we have solved, so you're getting the expression is equal to 28.64. So whatever code words you have generated, for A you have generated the code word is equal to 1, and for the code word B you have generated the value is equal to 0. So if you solve this method, you are getting a efficiency is equal to 28.64 you will be getting. But in the problem what they asked is, you need to have a efficiency at least 48%. So what we should do is, we should increase this efficiency. So how I can increase this efficiency means, I can go for the extension. So how I can go for the extension is, so in the original symbol what you have two symbols, that is A and B. So what is the probability you have? You are 0.95 and you have a 0.05, you had a probability. Now I will go for the second extension. If I go for the second extension, what you'll be having is, you'll be having a symbols AA, AB, BA and BB symbols you'll be having. Okay, so what are the probabilities? The probabilities will be AA, AB and BA and BB you will be having. So what is that? AA is nothing but 0.95 into 0.95. Second will be 0.95 into 0.05 and the next one will be 0.95 into 0.05 and the next one will be 0.05 into 0.05 you will be having. So if you substitute that, you'll be getting, the first will be 0.9025, second one you'll be getting 0.475 you'll be getting. Similarly, this will be 0.47 you'll be getting. Next one will be similarly, the last one will be 0.0025 you'll be getting. So these are the four symbols what you'll be getting for the second extension source. So these are the four symbols what you'll be getting for the second extension source. Now what we are supposed to do is, we need to arrange these in a decreasing order of their probability. So let us try to arrange them in a decreasing order of their probability. So if I arrange them in a decreasing order of their probability, what you'll be getting is 0.9025. Okay, next 0.0475, next 0.0475, next 0.0025 will be getting. Now what we should do is, we should divide them in such a way that the equal probability you supposed to get. Since the probability of the first one is extremely high, which is reaching to 1, whereas the remaining probabilities are low, so therefore what we can do is, I can group this as 1 and the remaining probabilities I can group this as 1. So this is the only one possible way where you can have a probability not approximately, somewhat it is equal to same. Okay, so for the first thing I will be assigning value 0 and the second being I'll assign a 000. Okay, so now what I will be doing is, again I will divide this, the first one will be as independent 0.75, the remaining I will be dividing into two groups. Okay, 0.025. Okay, so the first thing I will be dividing this and the remaining two things I will be dividing for these two. If I do that, what will be, again I will be assigning 0 and 0 for these two assigning. Again what I will do, I will be dividing this 0.75 and this will be 0.0025. I will be doing is, I will group this one more time and this I will be grouping this one more time. Again for this and 0 I will be assigning. Okay, so now for the code words for the first one, you can see I will be writing over here. The code word for the first one is 1. Next for this one is 0 1. Next 0 0 1. So the 0 0 1 and the next one will be 0 0 1. 0 0 0 you will be getting. Okay, so now once you got these 0 0 0, now what is the next thing is, you need to find out the average length L. You need to find out. So what is this average length L? That is nothing but, L is nothing but summation I is equal to 1 to Q Pi into Li. So what is Pi? The probabilities values, and the Li is nothing but the code vectors what you have. Okay, so if I substitute that, what will be getting is 0.9025 into 1 plus 0.0475 into 2. Okay, next plus 0.0475 into 3. Next, the last one will be 0.0025 into 3. So if you substitute that, you'll be getting Li is nothing but 1.1475 bits per symbol. You'll be getting bits per symbol. You'll be getting, that is a L value what you'll be getting. Now what we are supposed to do is, we need to find out the entropy of these symbols. You need to find out the entropy, that is the probability values you need to consider them, and those probabilities values you need to find out the entropy. So what is that? H of S is equal to summation. Now how many symbols are there? 4 symbols are there. So 1, 2, 3. That is nothing but Pi into log 1 divided by Pi. You will be getting. So if you do that, either you can solve this, or we also know that H of S square, that is the second extension, is nothing but 2 into H of. So we know this property, right? So if I use this, so 2 into what is the previous H of you got? So the previous H of you got, it is, that is nothing but 0.2864, you got it. So if I substitute that, so you will be getting the H of S is nothing but 0.5728 bits per symbol. You will be getting bits per symbol you got. Now what you are supposed to do is, therefore the efficiency is nothing but H of S divided by L. So if you substitute that, 0.5728 divided by what is L? L is nothing but 1.175. If you do that, so you'll be getting 49.92 percentage. So in the problem what they have asked, so they have asked you to find out 48, so you will be getting a 49. So therefore you can say the code words will be in this order. So for the AA you will be having 1, and for the AB you will be having 0, 1, for BA you will be having 0, 0, 1, and for BB you will be having a 0, 0, 0. So this is how we can able to create or construct a code words by using a source alphabet by using Shanon Fano encoding algorithm. Thank you.